My guess is 6-4 is gonna go very, very easy. 6-3 is most likely the most difficult section that you're gonna have, even though that's doable on its own. So, I was already helping people with homework on 6-3 yesterday. Start your homework so that you guys can find out what types of questions you may have difficulty with. And generally, the issues that you run into, once you get them explained to you, are pretty easy to overcome. 6-4 is mainly just properties of integrals. And it's mainly, but it's not completely properties. So we'll do it over 2 days. Honestly, I'm expecting it to go very well. The test we have coming up, if you prepare for it as if it's going to be difficult, you'll probably do very good. If I say it's an easy test, then too many people mentally don't prep for it because they just tell themselves it's going to be easy, and then they don't get ready for it, and then it works out like it did the last test. Jason, why are we on our phone?
Someone texted me.
Someone texted me too, but I'm not on my phone. Jeez, man, what do you do when you're driving?
You can't drive in.
Thanks. They are currently working on passing it to make it a law that you cannot have a phone in the classroom. And I am not against that.
So, what's the punishment?
Locked up in jail, life sentence.
Weirdly enough, I made it all through school without a cell phone to turn in my home.
Yeah, but they've changed the way you do classes.
I'm not.
So how'd you get up early?
What if you like I think the turn in my home is
There's
like your fucking blood pressure like plummets.
They'll adapt.
your parents get a crazy check from the state.
It's like, oh yeah, well, I mean, at least you don't have to pay the college.
Okay, let's go through this. We will call on people today. We will get interactive. Here. Okay, now the first thing. We have run into this, and it's technically not possible. Like, it's not actually a thing, even though we use the answers from it. Like, there's no such thing as negative area. Area represents how much space something takes up. You can't have a negative area, like it's just not a possible thing. But the way that we do these problems, we find the area under the curve, and the reason we're allowed to have negative area is because it doesn't represent area, right? Like, the area that we're finding stands for something, so we can have negative numbers. But area itself can't be negative, and so I actually like that it says dealing with negative area here, because the textbooks make a very big point of saying that you're not allowed to use the phrase negative area because it's not a real thing. But it absolutely helps you understand how to do the problems. So, you guys ran into this in these. Oh, yeah. If you are reading left to right, this is where some people ran into the questions in 6.3. If you are reading an integral from left to right like we normally read things, then above is positive, below the x-axis is negative. However, if you read the graph backwards, which would be right to left, if you read it backwards, then we read the information backwards as well. So if you are reading that direction, area above the x-axis is negative, below is positive. So most people find it easier to use one set and stick with that one set. And this is where a lot of the properties are going to come in. Now the actual properties, I don't think are listed until like the third page is a note. But I want to go there first, because I don't necessarily feel like we need to make a point of something before we talk about it. So on this page are the actual properties, and then we'll do some questions together. Who do we got first? Oh, was it Delphin?
No, I just had to make sure it's close.
Oh, okay.
6.
No one.
Oh, I mean. 31.
Imani?
I did the right answer.
I should pause before I ask you this question. I skipped over this on the first page. Do you guys need me to write down how to read this notation? I know I've mentioned it in class a few times, but do you want it written down? So, okay. So I'm back on page 1. This was at the bottom. Just how to read this. That way you can kind of answer the question I'm gonna ask. So this one says the integral from A to B. You read the bottom to the top. So we would say from A to B. And the reason they say from is because it doesn't matter if the bottom number is bigger or smaller than the top number. This is where you begin reading your numbers. This is where you move to. So this can determine right to left or left to right. So the integral from A to B of f of x, so you have to say what you're integrating, dx. I understand that dx means nothing to you right now, and that's fine. Just go with it. Now the parts. I'm generally not going to go by the specific names of the parts. The main thing you want to know is that the top number is generally referred to as the upper limit. The bottom number, the lower limit. And they literally name it by its position. It has nothing to do with the size of the number, it's where it is. This is called the integrand, but I don't really care if you know that name or not.
Integrand? You mean like
Wait.
the little funky S thing? That's the integrand?
Yes.
Oh, that's like cool name.
The whole thing is called the integral. The actual symbol is the integrand. But again, these aren't super helpful to know the individual names. The main thing you need to know, because you will be referenced lower limit, upper limit occasionally, and so it's important to know which number's which. Okay, so Amani, your question, I was going to ask you, what does that first property tell us?
You said you were gonna explain what the dx is
Yep,
later, right?
section 5.
Okay,
Wait, what page is this on?
I don't know, 2 pages, this is the 3rd page of notes, so 2 pages later.
53.
Yeah, mine aren't numbered, you said 54, you said?
354.
354, we are way into the packet now, huh? Imagine if this was all one big packet. It'd be like a book.
Makes sense. It's just-
Okay, I can guide you if you want some guidance. Yes, okay, this is the integral from A to A of f of x equals 0. What is that? What does A to A mean? I'm feeling deaf right now, I can't hear, I see your mouth move. Or can anybody help her out? Oh, should I make this a class-wide question? Does anybody know what that is? You should have when you did the homework in 6-3, but like 10 people turned it in, so how do you?
It doesn't move, it's just from A to A, so you're not.
Correct. A represents a number. So an example would be you guys yesterday in your homework were supposed to have filled out those tables, and you had to do like, say, the integral from 1 to 1. And if you start at a number and end at the exact same number, it doesn't matter what equation you have. The answer is 0 because you didn't move anywhere. You wouldn't have any area if you don't go anywhere. So this property is just saying, whatever this number is, if it's the same number on top and bottom, the answer's 0. Okay. You wanna keep going or you want somebody else to go now? Okay. Oh, well, you guys are alternating, okay. So we're going on to property 2.
10.
Who's 10? Okay, Max. Thoughts on the blue one?
Goes from A to B,
No. Read from bottom to top.
all B to A.
Yep.
And then that's basically just the opposite of minus.
Okay, so what is it telling us? So you're right. Yeah, the way you read it was good because you said A to B and then you said minus or opposite.
So it goes down.
Ooh. Once you understand what it's saying, it's basically saying very little, but it's actually super helpful.
Isn't the area from B to A is positive?
It's not wrong, but that's probably a difficult way to explain it to somebody. But it is correct, what you said.
Was it like what you said at the beginning, where like if you're reading a graph left to right, positive on top, negative on the bottom, and backwards
Perfect.
is the opposite?
Correct. If you are reading a graph going from B to A, and you decide to read it the other direction and go from A to B, the answer would be the exact opposite. So if, for whatever reason, you have some information given to you that is in a direction that you don't like. Let's say you are given from 5 on the bottom to -2 on the top. So that would be reading right to left. If you want to change it to say -2 to 5, you can make the actual, just switch everything around and say it's the opposite answer. That's all this is saying. It's saying that if you swap the numbers, you have to make the answer the exact opposite. But swapping the numbers sometimes is helpful because it's easier to process and to do. Okay, good. This one I feel like is harder to read it as a property than what it's actually telling us. Just curious if anybody knows what it says.
The area from A to B is the same as if you were to break it in two with a midpoint, oh not midpoint, but a point in between of C. So like if you were to like break it in between, you add them together, that's like the same area.
That is perfect. One weird part is that C doesn't actually have to be in between A and B. Yeah, but that's okay. That is exactly what it's intended for. But you can, it weirdly enough works, no matter what A, B, and C are. So the way that this is intended, what bothers me is that C is in between A and B. What this is saying is if you take the area from A to C and add it to C to B, what the heck? It's going to be the exact same as if you went A to B in the beginning. So the two little areas added together are the exact same as the one big area. But, so Sophia, you said it great, because you said C was in between A and B. But if you read this, C doesn't have to be in between. It was intended for it because that's the easiest explanation for your brain. But it actually still works if this A is 1, B is 2, and C is 10. It still actually works, it's just kind of weird. Yeah. Lastly, K is represented by a constant, which means just a regular number. And so this is the same properties we have for a lot of things. If you have a number multiplier, you can choose to do the number multiplier on the inside or the outside, whichever is more helpful. If you are integrating just a regular number, so if I draw y equals 3, it's a flat line 3 high. if I draw y equals 3 and I integrate from 0 to 5 of 3, I would just take a height of 3 times 5 minus 0. This one I don't think is really not crazily helpful, but I'll show you where we're going to use it. And then this one is the same as every topic we've had, from limits to derivatives to whatever. If it's easier for you to separate them by terms, you can. This is how they use them on the AP test, is they want to check to see if you understand properties. And so they won't give you an equation. Sometimes they'll give you a graph. Most of the time, they just give you bits of info. Like this says the integral from a to b is 8. Integral from a to, oh, excuse me. Integral of a to b of f is 8. Integral a to b of g is -3. And then integral a to b of h is 5 halves. Okay, fine. You have no idea what those equations and graphs look like, but you know their answers. So because of that, we can find out all these answers. I'm going to skip A. Well, no, I won't. Okay. I'm basically doing this section backwards from the way it's laid out, but to me it makes more sense that way.
12.
Nobody.
$32.
Maybe. Okay. I can give you some guidance if you would like.
Yeah.
The most common mistake is that it's like your eyes will automatically read this as A to B. Okay, but it's written as B on the bottom, A to the top, which is conveniently opposite that one. So this answer should be, no. Oh, that's -3, sorry. Yes. It's the opposite of the answer you were getting. If the numbers are swapped, you make the answer the opposite. Good. Okay? We're just going to get progressively a little bit harder each time. We'll go through this page together. We get done in what? 05. Okay.
26.
Audrey?
See, the 2 is the multiplier, but then is it just from, yeah,
Correct.
8?
So the 2 you can choose to multiply on the inside or outside. You said that was what, 8? Correct. The 2 is the main part of that. Do you want me to do one with the regular numbers with you, or can I kind of skip to harder stuff? Do D? Okay, sure. I mean, once you get the hang of these, it's like super simple algebra.
9.
Vincent. Max already went, so I was gonna call him. It's empty. So D, first thing I notice is that we have 2 different terms. Okay? So one of the properties is that we can do it as 2 separate problems.
Oh, because, wait. Oh.
So having that plus sign in the middle of the equation means that we can read them individually and do it as 2 separate things. So the second one, the integral a to b g of x, that answer is directly given to us, I think, right?
Yes,
-3, okay.
So it would just be 2 times d of x? Would it be 2 times d of x, like once you do the inside part?
2 times d of x.
Or, not d of x, but like the whole integral? I don't know. Because once you finish the inside, can't you just multiply it? Like the last question we did?
Like, are you trying to say take the 5 out?
Like, you combine 5 with the -3 from.
Oh, I got you. No, they're separate. We would combine it at the very end. The property right above this, what does it tell you to do if you have the integral a to b of k?
Okay.
Because 5 is like a k, 5 is a number.
You
What's the answer of the integral of k?
You multiply k by, the top number, b minus a.
Perfect. We don't know b and a, so it doesn't matter.
Yeah.
No, that's great. I think what you were somewhat trying to say to start with is, it sounded like to say to put them together once you're done, but that is correct. You have to find their answers before you put them together.
Okay.
One thing you could have done, I've had some students in past years tell me to bring this 5 out as a multiplier, and you can do that, it would be the exact same answer. If you take the 5 out as a multiplier, it would be 5 times the integral from a to b of 1, and so the integral of 1 would be 1 times b minus a. So it's the same thing.
How would you do C?
Well, we just did. This is the answer, 5 times b minus a. That's why I was backing up. Our desks must be sliding forward again. I'm losing all my, yeah, what do they call that again here? The bubble? Well, sure. Personal bubble? Sure. Sure. I do make stuff up all the time. You guys never even know that, because you don't know this stuff, so I could make it up all the entire year and you wouldn't know. F.
3.
Oh, you had that ready to go. Colin, F, hardest one on the page. Or do you want me to write the answer and you tell me why? Why is it 5 head? No, it does not say that. Yes. I said it was 5 head. Okay, but up above it, it says the integral from a to b of h of x. And this problem is the integral from a to 4 plus the integral from 4 to b. So how come that's the same as the integral from a to b? I think it was the green colored one up above. Oh, I guess it doesn't matter for you guys because you don't know. Okay, I'll scroll up. It is the green colored one. What does this one tell us? I think this is the one that Sophia explains. Oh, okay. If you have the integral from a to some random number plus the integral from that same random number to b, that is the exact same answer as a to b. So if you have the same number in between, that same number doesn't matter. It doesn't matter what the number is right here. I mean, it could have been 100 and it's still the exact same answer. So it's just one of the properties. So you guys will have to be able to kind of identify them when you see them. I mean, it'll take a little while. You guys want to try this one on your own? Sure. It's kind of a reverse problem.
What did you break up into interval?
how you should set it up. If you use the properties we've been told. The 3 times the integral. The regular number we can write as just that number times top number minus bottom. And then from here, it's kind of like a math equation. So we've got 4 times 4, 16. So I'm gonna subtract 16 from both sides. Uh, 28 is 18. Divide by 3, 6, correct. Now there's different ways to write it. I know this is like the official correct way. If you are doing this as scratch paper, like homework, it gets crazy annoying to write the integral over and over and over. It's just like when we were doing limits. If you have to repeat writing the same thing over and over and over, it leads to super bad habits where you just like start leaving stuff off. Like, I can almost guarantee that if I were doing this one on homework paper that nobody else would have to see, I would literally just write 3 times x, and then in my head I would do 4 times 4, and I would solve it that way. And so rather than writing this whole integral notation, I would just represent it with a variable because that's the same thing. But if you're doing this like on a question that somebody else has to read, like a test or the AP test, this is absolutely the notation you have to use. It's annoying, and that's okay, but make sure you guys use it. Who do we got next? We're gonna test your pre-calc skills, / maybe algebra 2, but I know you did it in pre-calc.
29.
You have a skill. Or should I just start calling on close people when we get a random test?
17.
Thank you. 17 is probably a number. Okay, Naomi? What's an even function? X squared is an example of an even function, but it doesn't tell us what an even function does. So we're going to need to know how an even function acts for us to be able to answer these questions, and how an odd function acts. So most people do exactly what you just did, where x squared is a great example of an even function, because it is. X cubed is also a great example of an odd function, because it is. But do you remember what an even function does?
Something with the domain, right, the positive.
Sure. If you're just explaining it to somebody, how would you explain an even function? That's kind of what I was hoping for.
Like, a bunch is like positive.
Negative x squared is also an even function, but it goes down. That's okay. I mean, you're on the right track, 100%. Are you trying to answer?
Yeah, don't the endpoints end somewhere.
No. I mean, they do, but that's not what we care about.
Well, I mean, I guess I was gonna maybe say the same, like the end behavior.
Yeah.
Sure, that is also true, still don't care. This whole section, this whole chapter, are integrals. What are we finding with our integrals? Like the answer. Area. Okay, so the endpoints, we don't care about the endpoints, we care about the area, space, how it looks.
It's the same when we were talking about the y-axis.
It is symmetric about the y-axis. So that means the left side and the right side look identical. So x squared is a great example of even because x squared is symmetric vertically. I mean, they phrase it symmetric about the y-axis. So you guys probably want to write a note to yourself in whatever wording you like to use that says what an even function is. So the left and the right side look identical. Okay, knowing that, it tells us the integral from 0 to 3 is 8. And then, if it's an even function, if we know this answer and we know it's an even function, what would this answer be? Yeah, it's just that easy. If 0 to 3 is 8, then so is negative 3 to 0. This is the 0 to 3 would be considered the right-hand side. So negative 3 to the middle would be the left-hand side. Oh, sorry, that's not for you. Left-hand side for you. Odd function. X cubed is an example of odd function. Now that we kind of have the idea of what we're looking for, does anybody know odd function? FYI, if I don't know if this is going to help you or not, here's the correct notation for an even function. F of negative x is the same as f of x. This means the left-hand side is identical to the right-hand side. If you put negative x in place of x, and you come up with the exact same answer you started with, it's called an even function. An odd function is if I put negative x in place of every x, and I get the exact opposite that I started with, that's called an odd function. Picture x cubed in your head. The right-hand side goes up. Left-hand side goes down. So the right-hand side, if you consider that f of x, the left-hand side would be negative x. It is the exact opposite answers. So if the right-hand side is above the axis, the left-hand side would be below. If the right-hand side is below the x-axis, the left-hand side would be above. Left and right are opposite. So this one says, if 0 to 3 is 8, like we just did on the previous one, what would be negative 3 to 3? So if the right-hand side is 8, what would be the left-hand side?
Negative 8.
Negative 8. So together,
0.
0. The left-hand side and the right-hand side would cancel out on odd functions. For area. This part is true. Oh, sorry, question.
What if the function is like shifted horizontally?
That it is not even or odd.
Okay.
Even and odd has to be around the center.
Yeah. And what if it wanted to find like the value from when it doesn't go like equally over the z?
You wouldn't be asked that.
0. Okay, so it wouldn't ask from like 3 to -4.
The only time they would bring up even and odd functions is when it would be,
Perfect.
yeah.
Yeah.
Yeah, because otherwise it like doesn't help you solve the answer. These are true. The bottom ones say that you can use geometry. Biggest issue I've had in past years is students don't know what it looks like to be able to use geometry to solve it. This one I think you do. If I draw this one, what would the shape be for area? Or not? Correct idea, wrong answer. But it is the correct idea. You could do it with a triangle, but it wouldn't theoretically be a triangle.
Like a trapezoid?
So this one would most likely be a trapezoid. You were, in your head, you were thinking going through 0, 0. If it goes through 0, 0, then it would probably be a triangle. But one, this one doesn't go through 0, 0, and it actually doesn't start at 0. So x plus 3 has a y-intercept of 3, slope of 1, and we would be finding the area from 1 to 4. So it would be a trapezoid, your favorite shape to find areas of. Second one. I'm thinking you guys don't really do this in pre-calc anymore, because most students in calc basically have zero knowledge of this. What's that shape look like? It's not V? I think that's what you're good.
Yeah.
V is absolute value.
Oh, is it the like?
Is it like
That.
this?
It's the top half of a circle.
Oh,
Top right?
I thought like the square root functions were like they go up and they kind of.
Square root of X is what you are thinking.
But there's an x squared in it.
Okay,
So I don't know.
do you guys remember what a circle equation is?
No. Oh, x squared plus x squared.
This is a circle that's centered at 0, 0. You traditionally are not going to be given a circle that is not centered at 0, 0. Just because of ease. So, well, yeah, you're not going to be given one that's not centered at 0, 0 because it makes it that much more difficult to solve. But you traditionally aren't given equations that aren't solved for y. So if this is solved for y, it would be plus or minus square root r squared minus x squared. So you have to get used to that equation. This would be a full circle. This is the top half of a circle. This is the bottom half of a circle. So the plus or minus gives you both halves to make the full circle. Yeah, after we stop recording, we're gonna move these guys. I don't like this. I need space. I'm not a little person, I need room. Okay, worst case scenario. Zach, how would you know what the shape looks like? What could you do? Oh, that's actually true as well. That was way more difficult than I was thinking. Yeah, just graph it.
On the exam, if you don't have a
No. I'm not gonna give you a question on an exam that you can solve with geometry. That would defeat the whole point of calc. Because that would be geometry. Do know, on the AP test, if you get a question that can be done with geometry, you're allowed to. So like if you know what something looks like, you don't have to solve it with the calculator. You're allowed to solve it any method. But you're not gonna get them, so. Let's stop there. I know a few people need to turn in their homework yet because not everybody's turned them in. I have gotten quite a few on 6.3 already, which is awesome. But it did worry me when a lot of people couldn't answer some of those questions about the integral from like 4 to 4. So I'm hoping that people aren't just like writing answers down just to get it done with. I'm hoping by now you guys have learned that that isn't gonna really help on the test. I think I put the due date Friday?
For 6.3.
Yeah.
It's
Is it
tonight.
Tonight? Sure, tonight, I was definitely correct.
We can make it Friday.
Yeah.
I didn't want to because I knew you would put it off
Yeah,
till
make
Friday.
it, make it tonight, make it tonight.
Every time I have extended a deadline, everybody turns it in at the extended deadline. Oh, correct, I made 6.4 due Sunday night, I think. Yep. I wanted to make sure you guys were working on kind of current homework. Otherwise, too many of you just put it off, and I can't like get too mad at that because I need deadlines for things and I procrastinate till the deadline's due. So I kind of feel like I want to make sure you guys have deadlines that would help you out. Otherwise, with a couple minutes left, I can help people that have questions since so many people didn't get a chance to ask questions yesterday. But before we do too much,